Good afternoon, everyone. Dear authors and invited guests, welcome to the technical session 6C. Myself, Siddhi Auti, and I'll be your session moderator for today's session. On behalf of Global Knowledge Research Foundation and GR Scholastics LLP, it is my great pleasure to welcome you all to the 10th International Conference on Information and Communication Technology for Competitive Strategies. The 10th edition of the conference is being held or organized in a hybrid mode. The physical event was held yesterday in Jaipur, and the virtual event is being held via Zoom meeting on 16th and 17th of December. I hope you all will enjoy today's knowledgeable and interactive session. In this session, we will be having in total 10 presentations. Each presenter will be given a time span of 10 minutes, and after 8 minutes, I will be raising a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. And if you face any technical issue or query, please let me know in the chat box and our team will try to fix it. Now, just before we get started with the session, I would like to introduce you all to today's session chair, Dr. Kalpesh Popat. Dr. Kalpesh is an associate professor at Marwadi University, Rajkot, Gujarat. With over 20 years of teaching experience, he has published more than 30 research papers in international conferences and journals. His research interest includes mobile computing, Internet of Things, artificial intelligence, and machine learning, and cybersecurity. Welcome, sir, to today's session.
Thank you, ma'am.
Okay, now
Thank
we
you,
will
ma'am.
go. Thank you, sir. Now we will move forward to the first presenter. So the very first presenter is Neeta Dakare from Dattamegha Higher Education and Research University. And the paper title is Comparative Review of Support Vector Machines and Neural Networks for Early Prediction of Chronic Kidney Disease. Ma'am, if you're there in the meeting, please start with your presentation. Okay, I think she has not yet joined. No issues. We can start with the next presenter. So the next presenter is Trupti Kapse from Datta Mega Higher Education and Research. And the paper title is A Machine Learning Approach to Variant Voice Pattern Analysis for Depression, a Comprehensive Literature Review. Trupti ma'am, if you're there in the meeting, please start with your presentation.
Everyone.
Okay. You can start with your presentation, ma'am.
Yes, ma'am. Just a minute. Paper ID is 290. My paper title is A Machine Learning Approach to Variant Frequency, and the co-author of my paper is Dr. Dhananjay Deshpande, sir. So now I'm starting my paper. So introduction is major depression disorders is a leading cause of global. Can I, once again? Yeah, global disability, and the current relief on subjective matters such as the clinical interviews and the questionnaires like the BDI second and uh, so
Ma'am, your voice is breaking.
biomarkers limit accurate and early detection, and the speech reflect is combined with uh, okay. Yes, now it's clear, ma'am. It's visible and properly audible,
Yes,
ma'am.
yes, it is. Yes, ma'am. Please resume.
Okay, okay, ma'am. Thank you. So, the introduction of global disability and the current diagnosis release on subjective methods such as clinical interviews and the questionnaires like the BDI, DSM, and the absence of objective biometrics limits and early detection. And the speech signals reflect cognitive, and psychological changes caused by this assessment. This review synthesizes the recent studies on acoustic features, extractions, detections, and the psychological basis of voice changes in depressions, like the neurological changes, cognitive symptoms, and motor symptoms, and use with the acoustics biomarkers, we can detect the depressions. So, depression causes measurable alteration in acoustic feature due to neuropsychological and motoric disequilibrium. Motor symptoms, like the psychomotor retardations, directly impact speech, lead to lower accuracy, slower speech rate, and reduced voice intensity. And the cognitive symptoms manifest as longer pause time, decreased semantic fluency, and altered prosodic patterns like the impaired processing. Specific acoustic impact correlative with depression severity and response to treatment, providing empirical evidence of voice as a biomarker. Some related acoustic changes in depression in the detected. Reduce zero variability, reflect a content effect, and in the prosthetic features, reduce pitch range, longer pause speech, slower speech, and reflecting the symptoms. Energy features reduce vocal density, and the temporal features increase silence duration and reduce speaking time ratio. Processing delays. This is third. There is variations in the machine learning techniques. Now in the previous we are using the traditional business processes to now advanced deep learning like the CNN, RNN transformers. In the 2001 to 2012, we are using the traditional signal processing. Now, and TLS to 2015 is in machine integrations for the detecting the depressions and the rare technologies in the 21 to 25 advanced neural networks. So in the advanced neural network, we can use pre-trained models where 2.0 transformer architecture and multi-mode sections methodology. So we use the traditional acoustic features for the MPCCs techniques, prosodic features, spectral features like the jitter, shimmer, pitch, variability, and for this uh, or approach, we are using some standardized toolkit, using technique the last scale, low level descriptive, like the that is the LLD's statistical function. Example as mean, variance, range of different range of LLDs, and using the open smile toolkit, the managed features of extract. The deep learning features, automated features learn from a raw audio or presentation. Features from a raw audio or visual using the CNN, RNN, SPM, like the pre-trained models. And in the hybrid approach, combinations of handcrafted like prosody, MRCC, and the deep learned features. And this technique for the some tools, the combination of for this hybrid approach. High promising for spectral signal analysis for speech representations. Model using CNN have already worked on machine learning, and STM models have been created for emotions.
Siddhi madam, only I am facing the issue in this presentation, or you are
No,
also
sir. There is a bit of voice audio problem. I
okay?
think network
Because I
problem.
think like from my side maybe the issue, but voice was totally
Mm,
breaking. That's why I've asked you.
yes, it was
Okay, fine.
breaking in between, and then it was fine later on, again breaking. But ma'am,
Okay.
we are past the presentation time. Can you get to the conclusion?
Yes, ma'am, sure. Conclusion is high accuracy, 80 to 90%, 95% achieved using ML model. Deep learning improves early depression detections, and voice analysis enable non-invasive clinical screening, and symptoms can integrate with digital health platforms. And overall, the findings, the use of machine learning in voice pattern analysis, depression is a significant, rapidly developing field with enormous clinical potential. And also, data and ethical concerns and explainability remains challenges for this depression detections. And the ultimate goal is to translate this research finding into objectives readily available and continuous mental health measurable tools that complement existing diagnostic techniques. That this is the conclusion from this using the difference reference. Thank you.
Thank you, ma'am, for your presentation. Are there any
Thank you.
questions?
Madam, can you go to your title slide, please?
Yes, sir.
Uh, you are saying that you are working on approach to variant voice pattern analysis for
Yes.
depression. Okay. And in last conclusion slide, you are telling some mental health. So can you relate both the things?
Yes, sir. We are using for the difference machine learning algorithms to difference voice patterns for the depression detections. So, as per the acoustic features, voice patterns, different analysis voice patterns, or the acoustic features, we are taking the different accuracy with the help of different algorithm, machine learning algorithm.
Okay. Thank you, ma'am.
Yeah.
Siddhi ma'am, can
Thank
we
you.
have
Yes, sure, sir. We will go on to the next presentation. Okay, so the next presenter is Marita Topin from University of Pretoria, South Africa. And the paper title is A Proposed Framework for Promoting Youth Employability by Providing IoT Skills for Smart Agriculture in a Developing Country Context. Ma'am, if you're there in the meeting, please start with your presentation. Ma'am, please start with your presentation.
Hello, good afternoon. I'm just
Hello.
trying to share the presentation. I just need to provide some permissions. Can I quickly exit and come back? Permissions.
Okay, okay, so you can come back and share your screen.
All right, thank you.
Is there any issue?
Okay, I have managed to come back and share. Please just confirm that you can see my screen.
Yes.
All right, lovely. Good afternoon, everyone. My name is Nigel Sango, representing the University of Pretoria. Our topic was titled A Proposed Framework for Promoting Youth Employability by Providing IoT Skills for smart agriculture in a developing country context. So just in terms of a background and motivation for the study that we were performing, we find that in developing countries such as South Africa, there are extreme issues of youth unemployment, looking at numbers over about 50% in that
Sir,
sense.
sorry for the interruption, but you have not shared your PPT. We can see the Zoom tab.
Is it, let
So you
me,
have to go on the PPT.
okay, I am sharing on this screen. Can you confirm if that is fine now? Made it back. I hope I am able to share my screen at this stage. Just confirm if you can see it or it's still on
Yes,
the Zoom window.
it is still on the Zoom window. Please share your entire screen so when you're switching tabs, we will be able to see it.
Yeah, it only gives me the option to share from the window. And I can only select the actual screen. It's not giving me the option to share entire screen.
Okay. So what we can do is, you can share me your PPT in the chat box. But meanwhile, we
Uh,
will have another presentation so that we don't lose time. Just share me your PPT. I'll present on your behalf. Then you can give the explanation and ask me to change the slides.
Okay, sounds good. I will paste it in the chat.
Right.
Yes, sure.
Sorry, I'm Nigel's co-author. I can also try sharing. Oh, there it is. Not sure who's shared it now.
Okay, if you can share it, ma'am, please try it from your side. If that's
Okay,
possible, you.
I'm going to try to share. There we go. Share.
Yes, we
File.
can see your screen.
Okay, I'm just gonna try to get it on slideshow.
Okay.
Let me see. Maximize. Sorry. I
Yes, it would
will
be on the slideshow tab, I think.
sign as slideshow just begin from beginning. Can you see
Yes.
that now?
Yes.
Okay, so Nigel, if you want to go ahead, and I will change the slides. Is that all right?
Yes, that sounds perfect.
Okay, good. You can start.
Do it that way.
And
All
if I'm
right.
not awake, you can tell me to move to the next slide.
No problem. Sounds good. Apologies for the slight technical hiccup, but good afternoon, everyone. Nigel Sango is the name. Our topic was titled A Proposed Framework for Promoting Youth Employability by Providing IoT Skills for Smart Agriculture in a Developing Country Context. The study was done under the University of Pretoria. And really, in terms of the motivation and background for this particular study, we figured and found out that we have a big unemployment issue, especially in developing country contexts, high unemployment ranging as close to 50% from an unemployment rate. But in the same light, we find that the Internet of Things is, in today's perspective, transforming agriculture through smart farming and creating new employment opportunities for these specific youth and graduates who are experiencing this unemployment in these environments. Now, the main conundrum is that a lot of these unemployed youth pretty much lack the core skills that are needed to participate, especially in IoT related skills opportunities, which created an opportunity for us for this systematic literature review, which was conducted to really understand the skills that are primarily needed for promoting that employability among the unemployed youth, especially with a specific focus on unemployed graduates. So the study was really aimed at investigating the skills that are really needed to develop those IoT capabilities for the purposes of contributing to smart agriculture and equipping the unemployed with those specific skills so that they can contribute to parts of their economy. So with this in mind, our main research question was really centered around how can IoT or Internet of Things skills be best developed to equip the unemployed youth and specifically unemployed graduates in a developing country context for their participation in smart agriculture activities. Obviously, with this, we did have some sub questions that came out of that and thinking points in the sense of what are the specific skills that are needed to develop these IoT capabilities? What are the specific opportunities that are available in a smart agriculture context for the youths and graduates to actually participate in? And beyond this, what skills do you expect employed or unemployed graduates to inherently possess and obtain over and above the previous learning that they've already received in university studies? So going over to the next slide, this particular study, as you would have it, was a systematic literature review, as I've picked up. Yes, we can move to the next slide.
Oh dear. Sorry, I'm just struggling to get to the next slide.
No problem.
Not sure why it's moving.
Okay.
Okay, thank you.
Yes, all right, absolutely. So from a research method perspective, as I've previously pointed out, the research strategy was a systematic literature review. Some key search terms that we kind of really focused on in this study were things related to smart agriculture or smart farming, the unemployed youth, IoT education, which is the Internet of Things, developing country context, which really applies to countries such as South Africa and India as an example, our employment skills and job opportunities. And as far as the search period is concerned, we were really primarily looking at literature that is up until December 2023, with our oldest paper coming from 2012. From a database sense, we referred mainly to the ACM Digital Library, the Wiley Online Library, the Springer, Taylor and Francis, Jester, MDPI, Science Direct, as well as Google Scholar. And we also did extend our searches to some American journals, such as your International Journal of Smart Agriculture. And with this in mind, we were able to captivate or encapsulate about 337 records as far as articles were concerned. We systematically sifted through a Prisma diagram and Prisma methodology, where we then selected the papers that were relevant to our study, eliminating any duplicates and excluding papers that didn't necessarily apply. So you'll find that on the next slide from a thematic analysis that was performed. From our Prisma diagram, 337 articles were picked up, 77 were found to be duplicates. But in the end, we had 30 articles that were part of our literature review that we included. And part of this literature is what enabled us to come up with some of the specific findings that came out of this research, mainly around answering the questions of what are those needed skills that we discussed to develop that IoT capability for contribution in smart agriculture. And above that, what training is actually currently available for IoT education?
Sir,
And
sorry for the interruption, but we are past the presentation time. Can you please get to the conclusion?
absolutely. And in the end, the specific role that we have of the NGOs in participating from a skills perspective, we picked up that we had management skills that were critical, information management skills that were critical, communication skills as well, that could have been picked up and learned from that reality, as well as green skills, entrepreneurial skills. And essentially, from a conclusion perspective, what we did come up was with the framework. And in this framework, it really encapsulated things such as the specific skills that can be learned, such as working with sensors, working with artificial intelligence, opportunities within greenhouse and precision farming, the roles of government and private sector in ensuring this is a reality, such as funding IoT education, implementation of policies related to that, and some skills that were required from a graduate perspective are the soft skills, management, entrepreneurial, and the method of acquisitions would be different training programs such as a RIFA, diploma in computer engineering and IT courses. And essentially, what we then have from that is improved employability among unemployed youth and graduates in a South African context, or really you could call it in a developing country context. So, from a conclusive approach, we figured that smart agriculture is a growing field that can help reduce unemployment in developing countries. But the critical key component is ensuring that the youth and the unemployed graduates are equipped with such skills that are related to those IoT opportunities, giving them the ability to participate for their economies and assisting and helping and essentially being participants in a smart agriculture context. From a limitations perspective, this was obviously a qualitative research that is open to interpretation and generalizability of some of the findings. We believe that in future, our proposed framework can be practically tested and applied in real life scenarios. And from a contribution perspective, this research is primarily good at adding to literature related to youth employability and providing practical strategies for skill development in a smart agriculture context. And from a future research perspective, we believe that empirical testing of this framework plus mixed method studies and evaluation of those specific IoT training programs with a cost-effective analysis will essentially be useful in promoting that employability from a smart agriculture context. So that really was the crux of our research. We know we had to do it in a bit of a jiffy, but open to any questions at this stage.
Thank you, sir, for your presentation. And if there aren't any questions, we'll move forward.
All right.
Sunita ma'am has joined the meeting now. Ma'am, you can
Yeah.
start with your presentation.
Okay, ma'am. Yes. Good afternoon, ma'am. I'm Neeta Dakre presenting. Hello.
Ma'am, please start with your
Yes.
presentation.
ma'am. Good afternoon, ma'am. I'm Neeta Dakre presenting in ICTCS 2025. My paper ID is 233. Title of the paper is A Comparative Review of Support Vector Machine and Neural Network for Early Prediction of Chronic Kidney Disease. And I am from School of Allied Science, Faculty of Science and Technology, Datta Mege Institute of Higher Education and Research, Savangi Mege, Wardha. This is the content of my presentation: introduction, literature review, research gap, need of study, objective of research, conclusion, and references. This is the introduction of the topic. Chronic kidney disease (CKD) has emerged as a silent global epidemic. According to WHO, worldwide around 850 million people are estimated to have kidney disease from various causes. 10% of Indian population affected by CKD. CKD not only affect the quality of life but also place an immense burden on healthcare system worldwide. CKD characterized by gradual deterioration of kidney function over an extended period. Early diagnosis of CKD is crucial to improve the quality of life. This is the literature review. First study objective is handle class imbalance in CKD prediction. A clinical data set has 24 features. N is equal to 400. Model is SVM and smooth. Accuracy is 89%. Key findings are improve balance predictions for mandatory CKD cases, demonstrated effectiveness of data resampling. Second study objective is predict CKD stage using 4 algorithm. It has clinical and lab data. N is equals to 200. Model is PNN and accuracy is 86.5%. Key findings are PNN best first stages classification, highlighted early diagnosis. Third study objectives objective are compare 4 ml algorithm on public dataset. It has 25 features. N is equals to 400. Model is SVM and accuracy is 94.5%. Key findings are SVM outperform others, show ML potential in early CKD. Fourth study objective is predict CKD risk using 6 ML methods. It has public data set, 18 features. Model is SVM and accuracy is 94.6%. Key findings are larger data set improve accuracy, feature selection. Fifth study objective is develop hybrid ML model for CKD prediction. It has public dataset, 18 features. Model is hybrid SVM, ANN, and accuracy is 91.5%. Key findings, hybrid model outperforms single algorithm. This is the research gap. Despite promising advancement, research on kidney disease prediction using machine learning ML still faces several critical gaps, variability in accuracy across studies and algorithms, underutilization of ensemble and hybrid model for accuracy improvement, limited attention to feature selection and data quality of accuracy optimization. This is the need of study. Delayed diagnosis in traditional methods, importance of early detection, superior performance of ensemble learning, critical role of features engineering. These are the objectives of research. First, aim to understand suitable machine learning techniques for early kidney disease prediction. Research objectives are to study different machine learning techniques and existing early predictive model for CKD, kidney disease. Research methodology use, literature review of existing research on machine learning and early kidney disease prediction, analysis of existing early kidney disease prediction models. Second, aim is to assess the effectiveness of existing model. Research questions are to analyze model performance of different existing early predictive model for kidney disease. Research methodology use, collection and analysis of data set for early kidney disease prediction, evaluation of existing model using metrics like accuracy, precision, recall, F1 score, and AUC ROC curve. Third aim is to develop a novel model for early kidney disease prediction, improve accuracy. Research objectives are to develop a novel, accurate predictive model for kidney disease. Research methodology used are selection of suitable machine learning techniques based on objective 1 and 2, features engineering and data pre-processing, development and training of the novel model. Fourth aim is to compare the performance of the novel model. Research questions are to evaluate the model performance. Research methodology use, evaluation of the novel model using metrics like accuracy, precision, recall, F1 score, and AUC RLC curve. Comparison of performance. This is the conclusion of my topic. Machine learning holds significant promise for the transforming nephrology by enabling early prediction of kidney disease, which continue advancement in data collection, model development, and validation methodologies. This technology give the potential to become integral tool in clinical decision making, ultimately leading to better healthcare outcome for patient at risk of kidney disease. These are the references. Thank you.
Madam, can you tell us how will you collect the data for your research? Because to train
By
the
using
model,
Kaggle dataset.
okay, is it readily available?
Yes, sir.
And is there any ethical approval needed? Do you know about that?
No, sir.
please take care of it, because one of my research scholar recently faced this issue that whenever you are working with what I can say medical data, you have to take
Yes,
care for your ethical clearance of the data asset. That is, please take care
it
of it.
is a open source data, sir.
Then it's fine. But still, if it is having a what I can say the identity is there, then it will be difficult for you to use it.
Okay, sir.
Please take care. Thank you, ma'am.
Okay, sir.
Thank you, ma'am. Thank you, sir. Now we will go on to the next presentation. The next presenter is Ananya Joshi from Mukesh Patel School of Technology, Management and Engineering. And the paper title is AI Grid Georisk Intelligence for Disaster Resilient Healthcare. Ma'am, please start with your presentation.
Hello, is my screen visible?
Yes. Ma'am, are you presenting on behalf of Ananya Joshi?
Yeah, no, we both are going to present.
Okay.
Yeah. Good afternoon, everyone. So my name is Rishika Shinde. Me, along with Ananya Joshi, we're going to present our work titled AI GIS System for Resilient Healthcare Access in Flood and Storm Disaster Zones, which was a case study of Assam. So floods in Assam are not rare events. The annual, predictable, and yet devastating. So, what makes them especially dangerous is not just water, but loss of access. So, hospital gets isolated, roads disappear, medical responses arrive late, etc. So, most existing flood prediction systems they stop at saying where the water might go. So, they do not answer a more critical question of who loses access to healthcare because of it. And that gap is where our work begins. So, existing flood forecasting approaches primarily focus on hydrological prediction or like satellite-based flood data extent mapping. So while these methods are useful, they're largely static. So there are three limitations. First is they treat flood prediction and healthcare accessibility as different problems. And second, they rely on a single source of data, often, for example, rainfall alone, or like ignoring upward snow melt, terrain effects, etc. And third, the outputs are rarely deployable in real time. So as a result, disaster authorities often know a flood is coming, but they still do not know which hospitals will be cut off or like which routes will fail first. So to address this, we propose an AI integrated AIGS decision support system that combines multi-source environmental data, machine learning based flood prediction, and geospatial analysis to access healthcare vulnerability in flood prone areas. The system is designed to be predictive, spatially aware, and deployable in real time. So we integrated diverse data sets capturing the full hydrological story of Assam. So this includes rainfall and temperature data from Open Meteo and NASA GESDIC, the website. We collected the data from there, which also included snow and glacier melt from snow water equivalent data sets, elevation from SRTM, DEM, etc., and historical flood recurrence from the global surface water data set. So on the infrastructure side, we mapped hospitals, road networks, rivers, and population density using OpenStreetMap and WorldPop data. So rather than feeding raw data directly into the model, we perform targeted feature engineering to capture real world hydrological interactions. This allowed the model to learn nonlinear relationships between rainfall, terrain slope, soil moisture, and flood recurrence, while also improving generalization across different physiographic zones of Assam. So the purpose behind this whole project was to allow the purpose behind the model was to for it to learn nonlinear relationships between elevation, rainfall, soil, water saturation, etc. We also helped it minimize bias because caused due to skewed or sparse meteorological data. So these are the features that we had used feature engineering on. And so the machine learning model at the core of the system, it's a stack ensemble classifier. So we used histogram-based gradient boosting to model complex environmental interactions and cat boost to capture residual patterns and reduce overfitting on tabular data and logistic regression to provide calibrated probabilistic outputs. So this combination allowed us to balance predictive power with interpretability, which is crucial for data management systems where decisions must be trusted and explained. So this is where system fundamentally improves upon existing approaches. So instead of treating model outputs as abstract probabilities, we convert them into geospatial decision layers. So each healthcare facility is assigned a flood risk score, visualized through graduated symbology and Google Earth Engine. So we perform buffer analysis on hospitals around to access accessibility laws, identify the transportation bottlenecks, and generate flood hotspot density maps along the Brahmaputra basin.
Hi, I'm Ananya and I'll be taking over. So, like Rishika said, we've created this model to overcome the traditional problems. We propose an AIS GIS system that combines multi-source environmental data, ML-based flood prediction, and geospatial analysis. So, instead of using just raw data alone, we've also used feature engineering to capture real-world hydrological interactions such as terrain influence, cumulative rainfall. And then we've also integrated into a stacked ensemble model that uses CAT boost, histogram gradient boosting, and logistic regression. So why our approach is better? So first, because it is multi-source and context-aware. So by combining meteorological, hydrological, and geospatial data, the model can capture complex flood drivers that single-source systems often miss. Second, it is impact focused. So instead of producing abstract flood probabilities, we map risk directly onto healthcare facilities and transport networks. Third, it is operational and deployable. The system is implemented through a Streamlit dashboard that integrates real-time weather data and provides interactive visualizations. So, at last, to say that our model focuses more, instead of focusing more on monitoring floods, our model focuses on protecting healthcare access during floods. So, if you can see the graphs, Rishika, can we go to the graphs? As the user inputs their data on the Streamlit interface, for their own parameters like the longitude and latitudes that they want the information for. You get a specific range of graphs that are generated, and you also get a trigger that is an alert if your area is in high flood risk. So our model successfully achieved an accuracy of 72% and a recall of 80%. So this high recall indicates that the system is highly effective at identifying potential flood events before water levels rise to critical thresholds. So in context of disaster management, recall is more important than raw accuracy because the priority is to minimize missed threats rather than false alarms. So by reliably flagging flood risk in its early stages, the model enables authorities to issue warnings, mobilize resources, and alert communities well before flooding reaches inhabited or critical infrastructural zones. So, this aligns with our main objective of disaster preparedness, which is to detect every achievable threat early and provide timely alerts so that prevention actions can be taken rather than reactive response. Yeah, that's all. Thank you.
Thank you, ma'am, for your presentation. If there aren't any questions, we can move forward.
Ananya, can you tell me how you have compared your data? Means, have you proved that your output is better as compared to others? What is your
Because the
base
mod
paper for this? What is the base paper for this, and what is the output of that base paper? Can you have some table kind of thing for the same?
you mean as in like a classification report?
Mm, no, actually, you have said na that it is 72% and 80% and all.
Yes.
I am talking about that. Have you compared with your any base data or paper something?
No, not exactly based. It's just that we are using parameters more than the ones that are usually used in traditional systems. Like we're taking a combination of multiple parameters. So then using like past predictions of how floods have been
But
occurring all over
see,
Assam.
my question is, how can you say that your model is better? That is what I'm asking.
Because like our model integrates multiple like sources.
That is right. That is right. But you should have some comparison, na?
Right.
I'm just telling you, you can improve it in your next paper. That is better. Okay.
Yeah,
So
got it.
Thank
also
you.
to answer your question, we trained our model on the same historical flood labels and environmental conditions which were used by baseline approaches before. So that
Okay.
is where we ensured that the comparison was fair.
Okay, thank you.
Yeah.
Thank you, ma'am. Now we will go on to the next presentation. So the next presenter is Ashwini Kale from Datta Mega Higher Education and Research. And the paper title is Effectiveness of Mindfulness and Self-Practice Meditation in Reducing Workplace Stress Among Corporate Employees. Ma'am, if you're there in the meeting, please start with your presentation. Ashwini Kai, if you're there in the meeting, ma'am, please start with your presentation. Okay, there is no response from her side, so we can go on to the next presentation. So the next presenter is Rabindra Sharma from Symbiosis International Deemed University, and the paper title is Generational Differences in HR Self-Service Technology Adoption, a Systematic Review and Implication for the Nepalese Banking Sector. Sir, please start with your presentation. Sir, please unmute yourself. We cannot hear you.
Yeah. So thank you, Siddhi ma'am, Kalpesh sir, and Trupti ma'am. Uh, on behalf of my team member, I'm presenting on generational difference in HR self-service technology adoption, a systematic review and implementation for the Nepalese banking sector. My co-authors are Jaya Chitranshi. She's a professor doctor in Symbiosis International University, Pune, and associate professor Dr. Kapil Khanal. He is in Tribhuvan University, Kathmandu, Nepal. And mhm. Okay. The introduction starts here. The previous studies, on this sector has shown that EHRM improves employee engagement, satisfaction, and organizational performance. And millennials and Gen Z are comfortable with HR technologies, while Gen X may face digital anxiety and they need support. And in case of Nepalese banks, generational differences in self-service portal adoptions are still not well studied. That informs us to do, this study. And this study reviews existing evidence to identify key drivers, barriers, and adoption pattern across generations. The finding aims to help Nepalese bank design inclusive and generational sensitive digital HR strategies. So we have found these three research gaps: limited focus on generational differences in Nepalese digital HR research, limited use of established theories like TAM, UTAUT2, and lack of empirical evidence on SSP adoption across different generations. And our objective is to systematically review generational differences in human resource self-service portal adoption with Nepalese banking and provide actionable insight for inclusive generation sensitive digital HR strategies. We have developed one conceptual model which shows that performance expectancy, effort expectancy, social influence, and hedonic motivation, as well as facility conditions, enhance the behavioral intention to use SSP. And it is moderated by generational cohort, Generation X, Millennials, and Gen Z. So literature review summary I'm presenting here. Digital HRM, which enhance employees' engagement, flexibility, productivity, and job satisfaction in banking. Nepalese studies confirm its role in workplace transformation and management with global HR standards. Generational cohort theory explains differences in technology adoption. Millennials and Gen Z show higher confidence, ease of use, and positive attitude towards digital HR and self-service portals. While Generation X is more cautious, often experiencing techno stress and require organizational support. Regarding technology acceptance model, it highlight perceived usefulness, ease of use, habit, and hedonic motivation as key drivers of SSP and EHRM adoption, with clear generational variation. Regional and Nepalese evidence, we have found, growing HR digitalization, but persistent gap due to training deficiency, usability issues, and cultural alignment and generational expectations. So methodology we have, as mentioned in a topic, the systematic literature review (SLR) was conducted, and which was followed by Prisma guidelines to ensure transparency and rigorousness. And data sources, we have collected data from Scopus Web of Science, ACM Digital Library, Google Scholars, and SIO Digital Library as well. We have, source into five thematic dimensions. Those are technological term, banking context, generational cohort, adoption model, and regional focus, Nepal and South Asia. Inclusion criteria, we have included peer-reviewed English publications, from 10 to 25. Final samples, after screening about 140 studies, we came up to 33 studies selected through two-stage screening. Title and abstracts was screened first, and then after these 33 articles were reviewed fully. Data synthesis, narrative thematic analysis using a structure review matrix, and we did quality assessment also by applying MMAT, a tool. And among these all 33, we found, majority of study, 19 papers rated high, 11 medium, and 3 medium to high quality. And we followed Prisma, which shows here total records identified 120. And at last, we came up with 33 articles. Overview of results and generation patterns. Review of 33 studies identified three key themes in SSP RFs: adoption drivers, generational barriers, organization support. There is clear generation difference in how HR self-service portal are perceived and used, and international evidence from Europe, Southeast Asia, confirms context-specific adoption pattern. And Gen Z prefers fictionless, independent mobile-first system, and this finding highlights the need for generation-sensitive SSP design in Nepalese banks as well. So theme 1, SSP adoption drives, it shows that Generation X are driven by perceived usefulness and tax efficiency. There are a strong focus on performance outcomes, while millennials or Gen Y influenced by ease of use, peer norms, and organizational culture. Another Generation G, motivated by hedonic values, innovation, speed, and personalization. Strong preference for mobile-first experiences and integration of generation code theory. Generation code moderates adoption drivers. So theme 2, generational barriers, Generation X, technology anxiety. need for reassurance, and millennials disengagement due to outdated or inefficient system, and Gen Z they feel reverse anxiety, that is frustration when system
Sir,
fails to meet
sorry for the
high
interruption, but we are
high
past the
digital
presentation time.
expectations. Okay, I'm coming to conclusions and
Yes.
findings. Generation differences significantly shape SSP adoption. Gen X values practical usefulness but often experience technology anxiety. Millennials adoption driven by ease of use and social norms. Gen Z expects mobile first, frictionless consumer grade digital HR systems. Organization support is the most crucial, adoption moderator, but must be generation specific. Reverse anxiety, we have found this new thing. Younger cohort disengage when digital system fail to meet high expectations. So Nepalese banks need multi-generational HR tech strategies to ensure to enhance engagement and efficiency. And there are some limitation. The research is only focused on SLR model, and furthermore, future research directions we have uh, proposed. Thank you very much. Any queries, please?
Thank you, sir, for your presentation. And if there aren't any questions, we can move forward. So the next presenter is Rohit Patil from Shivaji University. And the paper title is Integrating Atmospheric Instability and Machine Learning for Analysis and Prediction of Extreme Flood Events in Kolhapur. Sir, you can start with your presentation.
Yeah, thank you, ma'am. Okay, is my screen visible?
Yes, sir.
Yeah, and it's in full screen.
Yes.
Yeah, thank you, ma'am. And good afternoon, everyone. Actually, I'm Rohit from Kolhapur, Rohit Prasanna Patil from Kolhapur, and actually, I'm a research scholar from Shivaji University, Kolhapur. So, in this paper, we are presenting we are studying the extreme rainfall events and the flood events happened in the Kolhapur district from past decades, and there are the two major events in 2019 and 2021. One second. Okay. So this is actually our introduction. In Kolhapur is located at the western Maharashtra region of the India within a Krishna River basin. So we can see these are the Krishna River basin, and the Kolhapur is located here. So the major floods happened in 2019 and 2021, causing the severe Cisco economical impacts. Means severe damage is happening because of the floods in the Kolhapur district. This study is used to understand the atmospheric precursors, and helps to explain why these floods is happen. So one of these precursors are the CAPE and the OLR. So CAPE is nothing but the convective available potential energy, and the OLR is nothing but the outgoing long wave radiation. These are the indicates that deep convection is happening over there for that time region. So their combined analysis improves the flood monitoring and the prediction, and the machine learning can further enhance the short-term rainfall forecasting. So the CAPE and OLR I will be explaining the next upcoming slides. So these are some images from the Kolhapur districts. So for the 2019, so we marked it as a prolonged and the heavy rainfall event for the 2019. So this is actually NH4 highway. This is blocked by the heavy rainfall and flooding event of that time period. So this is time period nothing but 10 to 15 days is happened in the 2019, and in the 2021 we marked as a flash flooding event. So this is only for 2 or 3 days event is there, but still the flood is happening, and the water logging is we can see in the residential areas. Next, before going to the paper objectives, the CAPE and OLR I can explain. So CAPE is nothing but the convective available potential energy, which indicates the atmospheric instability. So if suppose atmospheric is unstable, and if there is a high updraft is there, so clouds are come into the thunderstorm clouds like that. It's means indication. Then in the OLR, it's a proxy to the cloud top temperatures, and it's used for the deep convection and the thick clouds sensing. So coming to the paper objectives, this paper objective is to analyze the atmospheric instability during the 2019 and 2021 at the Kolhapur flood events using the CAPE and OLR along with the surface meteorological parameters. And next objective is that to compare long duration 2019, as we marked as a 2019 as a long duration, and in 2021 is a short duration. So the flooding mechanism, how it's why and how is happening, we are finding out that. To evaluate, the third objective is that to evaluate the usefulness of the CAPE and OLR anomalies for the different indicators, to develop machine learning models using the atmospheric and ground-based variables. So we are using also the ground-based variables and the satellite data that CAPE and OLR to access model and performance for the rainfall prediction during the extreme flood events. So the data, data and methods. The data we are collected from the IMD and the satellite. So ground-based rainfall and the surface meteorological data were obtained from the IMD, which the IMD with the Indian Meteorological Department, which has a station at Kolhapur district, and the satellite data that CAPE and OLR is obtained from the Copernicus Climate Data Store. That the ERA5 data is available, freely available for that region. And these two parameters are widely recognized as an indicator of the atmospheric instability. This is CAPE and OLR is indicator of the atmospheric instability. This is where many literature surveys are there, but base is 1976. The paper is there, and 2000 paper is there. So next one is this is a climatological mean for the rainfalls for the particular years. So we have taken this 14 years for this from starting from 2020 so 2011 to the 2024. So average of the annual is coming to the near about 1120. So as we see in 2019 is near about 1750, and 21 is also near about 1600. And also this comparison and anomalies over the Kolhapur we can see. In 2019, the annual rainfall is near about 1762, which is 57% more than the climatic average of the past 14 years. And again, in 2021 is near about 1570, it's near about 40% higher than the annual average rainfall. But in JJ is nothing but the June, July, August, September. This is monsoon period. Is near about 1564. The major contribution is came from the monsoon region, monsoon period only. And also it is near about 72% increase in the 2019 year, and near about 24% increase in 2021 years. So rainfall characteristics in 2019 as a persistence long duration rainfall in 2019, and in 2021 it is short duration intense rainfall. Primary impact is severe flooding and prolonged floods. This is a higher, this 10 days flooding is there. And in 2021 is localized flooding and the disruption. So this is actually spatial distribution taken from the IMD data. So actually in 2019, the overspread of this rainfall event is near about all towards the district. But in 2021 is concentrated towards the city area only. And this flash flooding is happening over there. And also in 2019, there are the dams are there, the water reservoirs are there. So still they are also get full, and the prolonged event is happened. So we got that in the analysis. Again in 2019, the OLR is nothing but OLR is as shown in here. One second. Okay, so average. Okay, the blue lines says that the average of the 2021 and 20 sorry to okay, I think I'm not showing it this. Okay, this 2019 is in orange line is indicate that the it's in near about 25 July 2019 is increasing in the OLR, sorry, okay, and near about is prolonged up to the 14th of the August, and is as compared to the OLR graph, the average is indicated the blue line, and this red line indicates the 2019 OLR data. So it is in almost the highest minimum, is near about minimum level. So in 2021, the sharp peak of the Kp value is happen, and again the sharp peak of the OLR also is happening in the same time period for the flood event. So the all these analysis we have keeping in the mind, and we are putting into the machine learning methods. So the IMD station data is used is a pressure, temperature, rainfall. Again, the RH means relative humidity and the wind speed. Again, then in satellite data and reanalysis data, we are taking as OLR and K. So data. So these are the actually the mechanism, the machine learning mechanism and flow chart. We can say it as that. Data pre-processing and future engineering we are into taking, because daily aggregation, missing values from the IMD data, missing values from the OLR and K values are is adjusted here. Multivariate predictor matrix is means we are forming the multivariate predictor matrix. Again, the machine learning models are random forest regression and gradient boosting as we are using. Then again, these models predict the rainfall. After predicting the rainfall, we are evaluating the model by observed values. So RMSE mean square error, and these are the we are calculating. So multi-source atmospheric data strengthen the rainfall prediction. Ensemble machine learning captures non-linear and rainfall atmospheric relationship. Event-based evaluation reveals model performance under the extreme events, and chronological event-based split we are using. We are not using the 80 and 20% splitting or 70 and 30% splitting. We are using the chronological event-based split. So for this, the station level pressure, the mean value we are taking into the model. Then dry bulb temperature, mean and max
Hello.
we are taking.
Sir,
Hello.
sorry for the interruption, but we are past the presentation time. Can you please
Yeah,
get to
yeah,
the
yeah.
conclusion?
Sure. Okay, so after that we are taking we are finding the f. F means nothing but the function which learned by the machine learning models. So this is actually output from our model. So from you can see the actual rainfall happening in the Kolhapur district is shown in the black line. Then the blue color line is nothing but the random forest predictor, and the orange color line nothing but the gradient boosting prediction. So we can say that the gradient boosting predictor model is performing better than the random forest predictor. And this is our model evaluation. So from for the model random forest regressor, the RMS is 22 and R square is near about the 0.54%, but gradient boosting having the RMS is 17.73 and the R square is nothing but 0.73. So we can say that the gradient boosting is regressor is capturing the more complex data and the cross correlation between these data. So my conclusion is the integrating the IMD surface data and with satellite atmospheric predictor, OLR and KP, the extreme rainfall prediction is can be formed, means which can be predicted. So Ensemble machine learning models capture nonlinear rainfall atmospheric relationship, especially during the extreme events. The chronological event-based space ensure the realistic model is assessment and the prevent the data leakage. The gradient boosting outperform the random forest with the higher accuracy and the lower errors. The framework demonstrates the strong potential and the extreme rainfall monitoring and the early warning system. Thank you.
Thank you, sir, for your presentation. Now we
Yeah,
will go
thank
on
you.
to the next presenter. So the next presenter is Soumya Hardagiri from PES University, and the paper title is LLM Augmented Hybrid IDS Framework for IoT Networks with RASA-based Analyst Interaction. Ma'am, please start with your presentation.
Yes, ma'am.
Sorry to interrupt, ma'am. I'm Ashwini.
Hello, ma'am. Ma'am, your presentation was
Hello.
on the...
Hello.
Hello? Ma'am, you were the fifth presenter, but I called
Ma'am,
out your name.
hello.
Hello? Yes?
My PPT is showing, ma'am, or not?
Ma'am, right now we are having another presentation. Can you please continue with your presentation after this one? I'm talking to Ashwini, ma'am.
Okay, ma'am, no problem. Okay,
Yes.
no problem.
Yes.
Can I continue, ma'am?
Yes.
So, good afternoon, everyone. Myself, Soumya,
And I'm Diya Prakash.
and our project title is LLM Augmented Hybrid IDS Framework for IoT Networks with RASA-based analyst interaction. So, this is our agenda for the presentation today. Starting off with the abstract, with the rapidly growing of Internet of Things, the number of connected devices has increased that significantly expanded the attack surface and also the complexity of the cyber threats. The traditional intrusion detection systems struggle to detect both known attacks and also unknown anomalies and often fail to provide understandable explanations for the analyst. Our work addresses this challenge and proposes a hybrid intelligent intrusion detection system that combines supervised as well as unsupervised machine learning with LLM based reasoning and a RASA conversational interface. In our framework, we have two models: a random forest classifier, which detects the known attacks, and also autoencoder, which identifies the anomalous behaviors. These two model outputs are then fused to improve the overall detection accuracy. The detected malicious traffic is then stored to the SQLite database, and an open source LLM, specifically the Gemma 2B via Olama, enables threat explanation and also automated firewall rule generation, while the RASA supports secure, context aware interaction. We have conducted our experiments on CIC IDS 2017, which shows high detection accuracy, timely automated response, and improved interpretability. Overall, the framework is scalable, adaptable, and also well suited for the IoT security.
So today IoT networks are everywhere. Like she mentioned, it's increased to a level where the cyber attack surface has expanded. So traditional intrusion detection systems struggle in these environments because they act as black boxes and just don't know why something was flagged. So in our work, we're going to propose a hybrid IoT ready intrusion detection system that combines supervised and unsupervised machine learning with a locally hosted large language model and a RASA-based conversational assistant. So this end-to-end approach improves threat visibility, response speed, and analyst confidence, making IoT security not just smarter, but also usable.
So the problem statement over here is that the IoT environments generate very high volume, heterogeneous, and also security critical network traffic that significantly expands the attack surface. Currently, the traditional intrusion struggle to adapt to the diverse IoT protocols and also the evolving attacks. So the current solutions that we have in our life is that ML-based idea solutions that often lack robust explainability. So our framework addresses this explainability problem, and we have because of this lack of explainability, there is a limit of trust, endless trust, delays response actions, all and also increases the risk of undetected threats, especially the zero-day attacks. So there is a high need of end-to-end IoT ready intrusion detection system that not only detects attacks but also gives actionable human understandable reasoning and automated mitigation support for the security analyst.
So, despite the significant advance in intrusion detection systems, there are four critical gaps that are still unaddressed. The first is explainability. So, most ML models, they act as black boxes. They flag traffic as malicious, but there's no human readable explanation, which is going to reduce an analyst's trust and it's going to slow down investigations. The second is there's no automated response. Existing ideas typically stop at detection, but they do not generate a actionable response like a firewall rule. Third is there's no conversational interface. Current IDS tools lack conversation. So analysts cannot ask something like, why was this IP blocked? Or what happened in the last hour? Which severely limits the real-time usability in IoT environments. And lastly, you have a poor LLM integration. So while LLM is very powerful, very few projects or systems integrate them directly into the IDS pipeline for threat detection, mitigation recommendation, or rule generation. Our work directly addresses all four of these gaps into a single end-to-end pipeline. This slide shows the end-to-end architecture of our proposed IoT intrusion detection. So at the top left, you can see the IoT devices that generate raw network traffic from heterogeneous environments such as smart homes or healthcare systems. This raw traffic is then processed by a feature extraction engine, which converts this flow-level data into structured features which is suitable for machine learning model. Then comes our hybrid machine learning analyzer, which combines random forest and autoencoders, and together you fuse this output to reduce false negative. Then you store this whatever has been flagged as malicious. You store it in a threat log database, and this is a centralized threat log database which acts as the system's memory for alerts, flows, and contextual metadata. So now you can go to the analyst, where instead of forcing an analyst to manually inspect logs, we're going to provide a chat-based interface where analysts can ask natural language questions. You can ask, why was this IP flagged? Or you can ask, show me the recent threats. These queries are then handled by a RASA-based conversational layer, which performs intent classification and entity extraction to understand the analyst's request. Then you have your LLM agent. So this lightweight LLM agent is going to query your threat database. It's going to build a structured prompt, and it's going to send this to a locally hosted LLM, which is going to reduce latency. So finally, this LLM engine is going to generate three outputs: your natural language explanation, recommended action, a mitigation action, and an auto-generated firewall rule. So this architecture transforms IDS from a detection tool into an explainable, interactive, and response-aware security system specifically designed for IoT environments.
So getting into the details of what we have implemented, the first layer includes the data collection layer, where in real-time deployment, we have planned to use the tools like Zeek and Suricata to capture the live IoT traffic. But currently for our project, we have used a pre-collected data set with flow-level features. And the second includes the feature extraction module, where we have processed the raw CSV data to extract only relevant fields like IP addresses, protocol, flow duration, packet size, etc. Next comes the hybrid ML analyzer, where we have the two models: random forest, which is the supervised learning, which classifies only the known attacks, and also the autoencoder model, which is an unsupervised learning, which detects the novel anomalies based on the reconstruction loss. Both these models are trained and tested, and the outputs of these models are then fused. So there comes the fusion logic,
I'm
where
sorry for
we
the interruption, but we are past the presentation time. Can you please go to the conclusion?
Yes, ma'am. So these are the results of our training and testing. And this bar chart actually shows compares the number of malicious flaws detected by the random forest autoencoder and the fuse decision. And these are the RASA outputs. Basically, when we when we ask the RASA what are the last 5 threads, it gives the output. And you can see that these are the 5 flagged malicious flows, we have these intent prediction confidence distribution and also the intent confusion matrix. Both of these histograms and the confusion matrix, the histogram demonstrates the confidence scores of RASA and LU component for both correctly and incorrectly classified intents. So all the predictions that were made were with very high confidence. There were no incorrect predictions observed. And for the confusion matrix that we have displayed, it perfectly shows the predicted versus actual intents, and the diagonal dominance shows 100% accuracy for all the 10 defined intents. There was no cross intent confusion occurred.
So overall, this work demonstrates how explainable conversational AI can transform ideas into an analyst-centric security system for modern IoT environments. Thank you.
Thank you.
Thank you, ma'am, for your presentation. And now we will go on to the next presenter. Ashwini, ma'am, you wanted to present after this one, right? So you can start with your presentation. You can share your screen now. Hello? Ashwini, ma'am, am I
My PPT
okay?
is visible now.
Yes,
It is
yes. You can
visible, ma'am.
start with your presentation. Yes, it is visible.
Okay. Good afternoon, ma'am and sir. My name is Ashwini Kade, and today I'm presenting my research paper. And my research paper title is Effectiveness of Mindfulness and Self-Practice Meditation in Reducing Workplace Stress Among Corporate Employees. These are content, introduction, research problem, research gap, research methodology, data analysis, research hypothesis, finding and conclusion. This is introduction. In today's fast-paced corporate environment, workplace stress has become a major concern, affecting employees' well-being, emotional resilience, and productivity. This study aims to evaluate whether mindfulness and self-practice meditation can act as effective coping strategies for managing workplace stress. This is my research problem. Respect the growing use of the mindfulness and self-practice meditation is corporate workplace. Their long-term effectiveness, reducing employee stress is not clearly understood. Limits empirical studies and the inconsistent implementation create a need system evaluate in the real workplace settings. This is research gap. Most exciting studies focus on the short-term outcomes and lack real-world implementation analysis. There is a limited evidence on the sustained stress reductions and workplace throughout self-practice mindfulness programs. Research methodology. The study follows a descriptive research designed to examine the effectiveness of mindfulness and self-practice meditation in reducing workplace stress among corporate employees using both primary and secondary data. Data analysis. Descriptive statistic techniques such as mean, minimum, maximum, and the standard evidence and the bid applies using SPSS software for to analysis workplace stress, mindfulness practices, and the well-being indicators. I'm audible, ma'am. Hello.
Yes, ma'am.
Hello.
Hello?
I'm audible, ma'am.
Yes, yes, ma'am, you are audible.
Yes. I have mouth ulcer, so my speech may not be very clear, ma'am.
No, ma'am, it's all right. We can hear you clearly.
Okay, thank you. object of the study to evaluate the impact of mindfulness and self-practice meditation on workplace stress, to assess the effectiveness of the mindfulness practices in improving workplace well-being. This is research hypothesis. Null hypothesis and mindfulness and meditation have not significant effect on workplace stress. Alternative hypothesis: mindfulness and and meditation significantly reduce workplace stress. This is my research finding. The research the 149 participants come from the various job roles, indicating a diverse work environment and a stress experience. Overall, participants reported moderate stress level, with the work-life balance remaining a major challenges and affecting. Mindfulness practices were moderately adopted among participants. Main engagement score 3.25 after presenting mindfulness. There was the moderate reductions in stress level, means stress reduction score 3.49. Participants also showed a positive improvement in emotional resilience, mean emotional resilience score 3.54. Enhance emotional state. Overall, mindfulness and meditation were positively pursued and found helpful in the coming with stress throughout. Where this is the conclusion. Conclusion is the final interpretation of explains what the finding mean and give an oral message. It is summary based and argument oriented. Thank you, ma'am and sir.
Thank you, ma'am. Thank you for your presentation. Sir, if there aren't any questions, I'll go on to the next presenter.
Please go ahead, Siddhi ma'am.
Yes. So there are only two more presentations left,
Fine.
and
Thank you.
this is one of the second last presentations.
Okay, sure.
Devaki Prasad from PES University, and the paper title is Prediction of Cyber Attack Driven Outrage in 5G Architecture Using Conversational AI Agents. Ma'am, please start with your presentation.
Yes, thank you. Is my screen visible?
Yes.
Just a second. Is it in full screen? Everything fine?
Yes, everything's all right.
Okay, thank you. Good evening. I'm Devaki Prasad, and today, on behalf of my team, I'll be presenting our work on predicting cyber attack driven outages in 5G architecture using conversational AI agents. The focus of this work is not just attack detection, but making those predictions interpretable and actionable for human operators. I'll briefly cover the problem, our proposed solution, the methodology and system design, followed by the results and conclusions. Adoption of 5G networks significantly increased the attack surface due to decentralization, cloud integration, and edge computing. This makes them vulnerable to multi-vector attacks such as thin flooding, black hole routing, and sinkhole attacks. While machine learning models can detect these attacks, their outputs are often confined to logs or dashboards, requiring expert interpretation. This delay in understanding directly increases outage risk. Our motivation is to bridge this gap between AI-based detection and human decision making. Hence, we propose a hybrid system that combines multiple ML models with a conversational AI assistant that predicts attacks, explains them in natural language, while also suggesting mitigation steps, thereby supporting both technical and non-technical users. This, at a high level, our solution is a hybrid AI-driven detection framework. It integrates an ensemble of ML models, with a RASA-based conversational assistant. The goal is to convert raw attack patterns into human interpretable insights in real time. This diagram shows the overall system architecture. The network logs are continuously processed and passed to a collection of ML models for attack prediction. The models send their predictions and relevant network details over to the conversational agent via API calls. The agent, with these predictions and a knowledge base of the attacks, generate clear explanations and mitigation guidance. The user never receives the raw model outputs, only actionable information. The system operates end-to-end as follows. First, the ML model continuously monitors the 5G network traffic. In the occasion where an attack is detected, the system automatically alerts the user. The user can then query the assistant, which explains the attack, its confidence, detailed network parameters, and the recommended mitigation steps. The system follows a modular layered architecture. It consists of data processing, prediction, conversational interaction, and mitigation logic. This makes the system scalable and suitable for real-time deployment. The system was evaluated using 5G traffic generated through OMNET simulations. The dataset with over 7 attack scenarios such as SynFlood, black hole, sinkhole, and evil twin attacks. Pre-processing includes data cleaning, encoding categorical features, and normalizing continuous parameters. We use 3 complementary ML models: XGBoost for its fast and accurate classification in tabular network features, Bayesian neural networks for its uncertainty-aware predictions, which is useful when attack signatures overlap, such as in the case of sinkhole and black hole attacks, and Echo-State network for capturing temporal patterns in evolving network behavior. Together, the ensemble proves robustness for the prediction. Models were trained using a 70-30 train-test split with cross-validation. We used scikit-learn, PyTorch, and RASA for implementation. Each ML model is deployed as a microservice and accessed by the conversational agent through custom actions. The RASA assistant was evaluated for its intent recognition and dialogue management. It achieved an approximate of 93% action prediction accuracy while maintaining conversational context across 6 to 7 turns and responding in under 2 seconds on average. In terms of results, XGBoost achieved the highest accuracy at around 95%. ESN showed strong recall for sequence-based attacks, while BNN was effective in scenarios requiring uncertainty estimation. This table is modeled as a graph as shown. The conversation interface is critical for interpretability. Instead of analyzing logs or dashboards, users receive clear explanations and attack-specific mitigation steps. This significantly reduces cognitive load and response time during incidents. In conclusion, integrating ML-based detection with conversational AI improves both predictive performance and operational usability. The system bridges the gap between cyber attack prediction and real-world mitigation in 5G networks. A key limitation of this work is reliance on simulation-based data. Future work for the same includes validation with live 5G traffic, expanding attack coverage, and continuous retraining to handle evolving threats. These are our references. Thank you for your time. I'll be happy to take questions. Ma'am, you're on mute.
Thank you, ma'am, for your presentation. Now we will go on to the last presenter of today's conference.
Oh, I'm so sorry.
So the last presenter is Philip Serrano from Cameroon's Sir Polytechnic Colleges, Philippines. And the paper title is Software Quality in Use Evaluation and Enhancement of E-Governance Supply and Property Inventory System for a State Universal in Bicil. Sir, please start with your presentation.
Hello, am I audible?
Yes.
Okay, good afternoon. I'm Philip Serrano, and this presentation discusses the evaluation and enhancement of an e-governance supply and property inventory management system using software quality in use metrics. Software quality in use directly affects how well systems support users and institutions. In this study, software quality in use is treated as a key determinant of user satisfaction, productivity, and operational efficiency in institutional systems. In public universities, government asset inventory systems are not only operational tools, but also a primary source of reliable institutional data. While artificial intelligence and machine learning are widely discussed today, these technologies depend entirely on reliable data, data that originates from high-quality systems. These three concepts summarizes the motivation of the study. Now, the next slide highlights the research gap that motivated the study. On the left are common challenges in existing inventory systems, including reliance on manual or legacy process, limited user-focused evaluation, and weak analytics foundations. On the right are the objectives of the study, which responds to these challenges through a software quality in use evaluation. Despite ongoing digitization efforts, many asset inventory systems are still assessed mainly from a technical perspective rather than actual user experience, and this study directly addresses that gap. This study followed the incremental development model, which consists of requirement analysis, design and development, implementation, testing, deployment, and maintenance. Each development phase produced a functional system increment that was refined based on user feedback. The outcomes of each increment were then evaluated using ISO/IEC 25010 software quality and use metrics, with assessments provided by both supply and property management office personnel and IT experts through a Likert scale survey. As part of the methodology, the study adopted the ISO/IEC 25010 software quality and use metrics as the evaluation framework. The quality attributes, efficiency, functional suitability, reliability, usability, maintainability, portability, and security served as the metrics that guided both system assessment and enhancement. This framework ensured that evaluation focused not only on technical performance, but also on actual system use and user experience. So this study used developmental quantitative research methodologies from data gathering up to system development, simulation testing, and interpretation of evaluation results. For these methods, I used total enumeration sampling. All 10 personnels of the Supply and Property Management Office were included because they are the actual end users of the system. In addition, 10 IT experts participated to provide an objective technical evaluation of the system. Thus, this ensured that both operational usability and technical quality were assessed. To measure software quality in use, I have employed 5-point Likert scale, which is a standard approach in software quality evaluation. Each response ranges from 1, which is highly unacceptable, to 5, which is highly acceptable. Highly unacceptable to highly acceptable, with clearly defined numerical ranges for interpretation. The results from the survey were analyzed using descriptive statistics, specifically the weighted mean, to determine the acceptability level of each software quality metrics. And after collecting the evaluation responses, the data were analyzed using descriptive statistics. Weighted mean was used to summarize Likert scale responses for each quality metrics, and the results were interpreted based on predefined acceptability ranges. Since this study adopted the incremental model, the results and discussions are presented according to each development phase, highlighting system improvements and their alignment with software quality and use attributes. The requirement analysis focused on 6 core transactions: purchasing, delivery and acceptance, equipment custodianship, supplies custodianship, disposal, and reporting. Major improvements were implemented in custodianship and reporting, including database optimization and compliance with new COA circular, while purchasing and disposal required no changes. During the design and development, system requirements were translated into functional modules with emphasis on efficiency, usability, and government compliance. A modular web-based architecture using PHP and MySQL database supported optimized data processing and incremental refinement, which strengthened the system's reliability, maintainability, and functional suitability. Then during the implementation phase, focused on translating the design specification into executable code, transforming the system architecture into fully operational modules. Key components such as purchasing, custodianship, reporting, and compliance were successfully implemented and made functional. Following implementation, iterative validation and testing were conducted to identify errors, performance bottleneck, and inconsistencies. So these refinements ensured that system accuracy, efficiency, and reliability improved with each release, resulting in an implementation aligned with the software quality metrics. Then this shows the actual testing and evaluation activities conducted within the Supplier Property Management Office. Testing was performed in a real operational environment using actual testing scenarios or transaction scenarios, allowing both functional and non-functional characteristics to be evaluated. This radar chart summarizes the evaluation results across the software quality in use metrics for both end users and IT experts. Overall, both groups rated the system as acceptable with an identical overall mean of 4.3, indicating that the system meets user expectation and institutional requirements. From the end user perspective, the highest ratings were observed in efficiency at 4.7 and usability at 4.6, reflecting faster transaction processing and improved user experience compared to the previous manual process. In comparison, IT experts provided more conservative ratings, particularly in usability at 4.1 and reliability at 4.2, suggesting areas where technical refinement and system optimization can still be applied. So both groups reported relatively lower scores in portability and maintainability, which highlights the need for greater adaptability and ease of system modification and future enhancements. So overall, the radar confirms that the system performs consistently across all quality dimensions while clearly identifying specific areas for continuous improvements. So for the deployment focused on preparing the system for full institutional use, a test run was conducted to evaluate performance and gather feedback, followed by hardware configuration, system adjustments, and user training. Close coordination with stakeholders ensured smooth integration into existing and supply property management workflows. After deployment, a structured maintenance process was implemented, which includes continuous monitoring, user feedback integration, bug fixing, regular data backup, and system updates. These activities ensures that the system remains reliable, secure, and aligned with software quality and use standards over time. So in conclusion, the evaluation shows that the CSPC Supplier Property Inventory Management System achieved an overall acceptable rating with a weighted mean score of 4.3 across all quality dimensions. The system demonstrated strong performance in efficiency, usability, and reliability, indicating faster transaction processing, improved user experience, and consistent system behavior compared with previous manual process. However, relatively lower ratings in portability and maintainability indicate that areas require further refinement to ensure long-term adaptability and ease of system modification. Overall, the findings confirm that improving software quality in use enhances operational efficiency and strengthens institutional governance. And based on the findings, several recommendations are proposed. First, future evaluations should adopt mixed method approaches that combine quantitative metrics with qualitative user feedback. Second, longitudinal assessment is recommended to track improvements in software quality and use over time. And third, stronger end user involvement should be encouraged throughout system enhancement activities. Finally, future development efforts should prioritize portability and maintainability, and institutions should institutionalize continuous evaluation to support sustainable e-governance systems. Here are the reference, and that's all. Thank you very much.
Hello.
Hello, sir.
Philip, can you go to your slide where you mentioned some numbers? Actually, you have not given the slide number, so I'm not able to tell you the exact slide number. No, one table was there where you written some 10 values or something kind of thing. Go back, go back, go back. Yes. So here, what I'm understanding is you have taken the response from 10 people. Am I right?
Yes, sir. 10 from the office and 10 from IT experts.
Do you think that this is sufficient data set for your calculations?
Because there are only 10 personals in the office, and from
That
the
is
IT
right.
experts, yes, sir.
That is right. That is right. But will it give the proper results? Do you think?
No,
As per my
but
opinion, it should not be, because when you compare or when you create a result with 10 people, it may be biased also.
yes, sir. But if I add more participants, they might not be they might not know the process of how to
That is right.
conduct. Yes,
But
sir.
then that you need to explain them, and then after you have to do that. But okay, next for future enhancement, you can remember these things. This is
Okay,
only
sir.
a
Thank you
suggestion
very
from
much.
my side. Sure.
Okay, sir.
Thank you.
Thank you.
Thank you.
That rounds up the last presentation, and we are done with today's presentation. So we'll proceed to the closing remarks. I sincerely thank our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for your support during the 10th version and all the previous 9 versions of the conference. We will be happy to have you in the 11th version in 2026. All the presenters would be getting their digital certificates via email within 2 working days. Publication will be live within 7 to 8 months. Kindly cooperate with the team of ICTCS. And I also thank our session chair for chairing today's session. A token of appreciation on behalf of Team ICTCS and Global Knowledge Research Foundation and partners. Thank you, sir, for your valuable time.
Thank you, ma'am.
Now, before ending this session, I would like to request all the participants to please turn on your cameras so that I can take a quick snapshot. We'll just wait for a few seconds for everyone to turn on their cameras. Okay, I've taken the snapshot. Thank you, everyone. This was a great session.
Thank you. Thank you, all the participants, and all the best for your future journey. Thank you. Siddhi ma'am, can I leave the meeting?
Yes, sir. We can leave.
Thank you.